Now in this video, we're going to take our discussion of total utility, marginal utility, and so we're going to expand actually on that example with the slices of pizza. We're going to add a second good, cups of Coke or Pepsi, whatever you prefer. And we're going to try to understand how do consumers go about in choosing the combinations of Coke and Pepsi or Coke and pizza rather, that a consumer might spend. So for this example, we've added here now, so just like we had before, we've got 3 columns to start with. So now it's number of cups or cans of Coke, 0 to 6, total utility that the consumer gets from each quantity of Coke, and then the marginal utility. And this part of our example is the same as from the previous video. Now we need to add in a couple more pieces of information. First, we need to know how much income does our consumer have, and let's say it's $10. And what is the price of a slice of pizza? And I'll just use P for pizza here. Let's say it's $2 per slice. And what's the price of a can or a cup of Coke? In our example, it's $1. Okay. So now what we're introducing here, we've got so for each of our 2 goods, we now have a 4th column in here that is the marginal utility, and here this is for P for pizza, marginal utility per slice of pizza per dollar. Okay. Why per dollar? Because we want to put this into a comparable way of looking at it across the 2 goods. Right? So, how could you directly compare? So the first slice of pizza has a total utility of 20, and so then a marginal utility of 20. The first cup or can of Coke has a marginal utility of 20. So does that necessarily mean you should have one of each? Well, not necessarily, because remember, the pizza is twice as expensive as the Coke. So how would you then figure that out? So that's why we're putting this into marginal utility per dollar terms. And so right here what we have is, think about it, if the marginal utility here is 20 and a slice of pizza is $2, then marginal utility per dollar is just 20 over 2, or 10, right? 16 over 2, 8. So we're just dividing in each case by 2. In this case, the price is $1, so we're just dividing 20 by 1, just simply, again, 20, 15, 10, 5, 3, and then finally minus 1. Now, of course, if we're trying to say then, well, if you've got $10 to spend, how will this consumer choose to allocate those $10 between slices of pizza and cans of Coke? So what we're looking for here is we are working with the notion, and this comes actually down from our theoretical model, which we're not deriving for you here, but ultimately what our model of consumer choice comes out and tells us is that consumers will choose the bundle, like in this case, the combination of slices of pizza and cans of Coke, where the marginal utility per dollar spent on our 2 goods is equal. Okay. So the marginal utility per slice of pizza per dollar and the marginal utility per dollar for Coke are equal. That is where our consumer will maximize utility. And so where can we see this happening in our examples here? So one place we see this obviously is at 1 and 1, right? So, at 1 here and 3, right, down here. So there's one possibility. But of course, if you have $10, how much would they be spending? They'd only be spending 2, and then $3 for the Coke. They're only spending 5. So that combination obeys our our utility maximization rule, but it's not exhausting all of the income. So where else do we see this? Well, at 3 slices of pizza and 4, do these with stars here, 4 cans of Coke. And what's true here? Well, so how much is this consumer spending? Well, to look at whether they're exhausting all of their income, simply take the price per slice of pizza times the quantity of pizza, and add to that the price per can of Coke times the quantity, right, the number of cans that they're consuming, and that'll give you the total spending. So in this case, at 3 slices times $2 per slice, that's 2 times 3 or 6, and then $1 per can of Coke times the 4 cans that we identified with this second bundle, 6 plus 4 is equal to 10. That exhausts all of their income. Now, what's going to be true at this bundle? So if we say, look, this is the one that we think is optimal. Total utility from pizza is 46, and then the total utility from those 4 cans of Coke is 50. So the total utility in this case, in this example, is 46 plus 50, or 96. Okay? So the total utility here is going to be 46 plus 50, which is equal to 96. And what we could show is if you tried to pick any other combination, right? So what if instead we had, say, 4 slices of pizza? If you had 4 slices of pizza, you'd be spending $8 on pizza, then you could only have 2 cans of Coke. Total utility then would be 52 and 35, which is 87. Or what if you wanted to have 6 cans of Coke, let's say, and only 2 slices of pizza? Because again, 6 times $1 plus 2 times 2 is 4. That would also exhaust our $10 of income. Well, in that case, you're getting 52 and 36, 88. Any other combination you try to pick will not yield as high a total utility of 96 that we get from the 3 slices of pizza and 4 cans of Coke. Okay. And so we can show this, and you can try to do this any number of ways with this example. You will see that utility is maximized where this rule is obeyed. Okay. And so what happens if it's not obeyed? Right? So let's go back, and so we'll take this one example. Let's say we go back to one of the ones I just picked out for you before. Let's say we're at 4 slices of pizza instead, okay? 4 slices and only 2 cans of Coke. Okay? What's true here? Well, in this case, the marginal utility per slice of pizza is 3, while the marginal utility per can of Coke is 15. Right? So in this case, the marginal utility of pizza is down at 3. That's much less than it is for the marginal utility per dollar of Coke, per can of Coke, which is 15. So what should happen in this case? We say, well, looking at our table, it's clear that consumers consuming too much pizza and not enough cans of Coke. So how would this consumer increase their utility? Well, they need to decrease the quantity of pizza. And what happens as they decrease the quantity of pizza? Notice that the marginal utility per slice of pizza is going up. Right? That's going to go up from 3 to 5. And as they increase correspondingly their consumption of Coke by 2 cans, because by giving up a slice of pizza, that frees up $2, which lets the consumer buy 2 more cans of Coke, right? They now go down 2, so that the marginal utility per can of Coke per dollar drops to 15, and that brings us back into equality given our utility maximization here, using this equation. And so that's how we can look at this. So if you have the case where the marginal utility per dollar spent on pizza is lower than it is for Coke, that tells you you need to consume less pizza and more Coke, and that will help the consumer get to greater total utility. Okay. So this is how we look at using this utility maximization rule. And again, it comes from the theoretical model, which we're not developing fully for you here, but that, you can always look in the appendix actually to see at least the graphical representation of how we arrive at this rule. So the next sections of our chapter talk about behavioral economics. There's no formal video for those sections, but we will be discussing those concepts in class.